In 1854, a collector named Francis Link found a massive fossilized jawbone in the Ohio River near Evansville, Indiana. The teeth were unlike any living wolf, robust, powerful, designed for crushing bone. Geologist Joseph Granville Norwood sent the specimen to Professor Joseph Leidy in Philadelphia, one of America's leading paleontologists. Leidy examined the jaw. Clearly a predator, clearly a wolf, but larger than any wolf alive. In 1858, he named it Canis primevus, the primeval dog. Over the next 50 years, more fossils emerged across North America, from Nebraska, from the Mississippi River Valley, from Mexico, Peru, Venezuela. Scientists debated what this creature was and how it related to living wolves. Then, in the early 1900s, something extraordinary happened in Los Angeles. In 1908, paleontologist John Campbell Merriam began systematic excavations at bubbling asphalt pools in Los Angeles. Beneath the tar lay a mass grave tens of thousands of years old. Saber-toothed cats, giant ground sloths, American lions, mammoths, and thousands of wolves. By 1912, Merriam had enough complete skeletons to formally describe the species. He adopted the name Canis dirus, the dire wolf, standing 38 inches at the shoulder, nearly 6 feet long, weighing up to 150 pounds. Massive skull, bone-crushing jaws more powerful than any modern wolf. But Merriam noticed something else. The skull was different from gray wolves in subtle ways. Smaller brain case, more robust teeth, wrong proportions. In 1918, Merriam published a bold proposal. The dire wolf belonged in its own genus, Anacion dirus, terrible wolf. The scientific community rejected the idea. The differences seemed minor, surely just a large wolf. Merriam's proposal was discarded. The dire wolf remained Canis dirus. For the next 100 years, everyone believed the dire wolf was simply a bigger wolf, a close cousin of the gray wolf. They were wrong. The La Brea tar pits are deceptive. They look like dark pools of water, but beneath is thick, sticky asphalt. 40,000 years ago, thin layers of water would collect on top, masking the tar. An herbivore, a bison or horse, would step in and sink. The more it struggled, the deeper it sank. And predators heard the distress calls. Dire wolves, hunting in packs, saw easy prey. They moved in, and they too became trapped. Saber-toothed cats followed and sank. Over thousands of years, the tar pits became mass graves. The preservation was extraordinary. Bones, teeth, even fur survived. The predators vastly outnumbered the prey. For every bison trapped, dozens of dire wolves followed. To date, over 3,600 individual dire wolves have been recovered from La Brea. The most common large mammal at the site, only 15 gray wolves have been found. The dire wolf wall at the La Brea Museum displays over 400 skulls, row after row. A haunting reminder of an apex predator that dominated Ice Age North America. But the abundance raised a question. If dire wolves were so successful, why did they disappear while gray wolves survived? In 2021, paleontologist Angela Perry and geneticist Kieran Mitchell led a team collecting dire wolf fossils across the United States. Their goal: extract ancient DNA and sequence the genome. The La Brea specimens, soaked in asphalt for millennia, had destroyed DNA. But other specimens from Ohio and Idaho still contained fragments. 46 samples tested. 5 yielded usable DNA. In January 2021, the results published in Nature shocked the scientific community. The dire wolf was not a wolf. The lineage had split from gray wolf ancestors nearly 6 million years ago. For context, humans and chimpanzees diverged 6 to 7 million years ago. Lions and tigers split 3.9 million years ago. The dire wolf and gray wolf were further apart than cats and dogs. Closest relatives? African jackals. The dire wolf evolved in the Americas, isolated for millions of years. It was the last survivor of an ancient New World canid lineage with no living descendants. Gray wolves evolved in Eurasia and reached North America only about 20,000 years ago. When they encountered each other, they looked similar and hunted similar prey. But genetically, they were as different as foxes and wolves. The genetic data revealed something else. Despite living side by side for thousands of years, they never interbred. The genetic barrier was absolute. The research team resurrected Merriam's 1918 proposal, reclassify as Anoscion dirus, a genus unto itself. The lonely last member of a lineage that once dominated the Americas. For over a century, artists depicted dire wolves as gray wolves. Bulky, gray-furred, timber wolf proportions. The genetic revelation changed that. Dire wolves lived in the warmer southern regions of North America and South America, not the Arctic. Their fossils are found in temperate grasslands, not frozen tundra. Modern canids in warmer climates tend toward different physical traits. Red or brown fur instead of gray, bushy tails, rounded ears for better heat dissipation. Researchers now believe dire wolves may have looked less like a timber wolf and more like a giant reddish coyote. Reddish-brown coat, larger head, more robust build, but adapted for warm grasslands, not snow-covered forests. The skull confirms this. The dire wolf's skull was proportionally larger than a gray wolf's, with a smaller brain but more powerful jaws, built for crushing bone. Dental studies show extensive tooth wear and breakage. These wolves were biting into bones, processing every part of a carcass, scavenging as well as hunting. They were pack hunters, like gray wolves, but specialized, adapted for taking down Megafauna Ice Age horses, bison, even young mammoths. And that specialization, it turns out, was their downfall. Around 13,000 years ago, as the last Ice Age ended, North America underwent dramatic shifts. Glaciers retreated, forests expanded, grassland shrank, the megafauna began to disappear. Ancient bison, horses, camels, ground sloths. Climate change reduced food sources for herbivores, but there was another factor: humans. Paleo-Indians arrived in North America by at least 15,000 years ago. Skilled hunters targeting the same megafauna dire wolves depended on. As prey populations dwindled, dire wolves faced crisis. Their jaws were built for crushing large bones. Their hunting strategies evolved for pack takedowns of massive animals. They couldn't switch to smaller prey. Gray wolves could. They were generalists, opportunistic. They hunted deer, rabbits, even fish. They could survive on varied food sources. And dire wolves couldn't interbreed with gray wolves to gain adaptive genes. The genetic barrier was absolute. By 10,000 years ago, the dire wolf was gone. The extinction was rapid, possibly within 100 to 1,000 years. No descendants survived. The entire Anoscion lineage ended. In 2015, Game of Thrones brought dire wolves back to popular consciousness. The show exaggerated their size dramatically, but captured something true. The dire wolf was formidable, powerful, an icon of a lost world. Today, the Brea Museum displays that wall of 400 dire wolf skulls. Each tells a story of a specialized hunter that worked brilliantly for hundreds of thousands of years, until it didn't. Specialization is powerful. It allows a species to dominate its niche, but it's also fragile. When the world changes too quickly, specialists can't adapt. The gray wolf survived. It spread across the northern hemisphere. It gave rise to dogs. The dire wolf, isolated for millions of years and perfected for a specific world, couldn't change when that world disappeared. In April 2025, biotechnology company Colossal Biosciences announced they had brought the dire wolf back from extinction. 3 puppies, Romulus, Remus, and Khaleesi. They extracted DNA from a 13,000-year-old tooth and 72,000-year-old skull. They identified 20 genetic differences affecting appearance. They used CRISPR to modify gray wolf embryos and implanted them in dog surrogates. The result: pups with white fur and slightly larger skulls. The scientific community was skeptical. These weren't dire wolves, critics argued. They were genetically modified gray wolves, designer dogs with a few superficial traits. True de-extinction would require reconstructing the entire genome, thousands of genes, not just 20 edits. Moreover, even if you could create a genetically perfect dire wolf, where would it live? The Ice Age world it evolved for no longer exists. The megafauna it hunted are extinct. The controversy highlighted a deeper truth. Extinction is not just losing a species, it's losing an entire ecological web. The prey, the habitat, the climate that sustained that species. You can't bring back one piece and expect it to function in a world that has moved on. Somewhere in North America, around 10,000 years ago, the last dire wolf died. Perhaps it starved, perhaps disease, perhaps killed by gray wolves competing for resources. With its death, an entire lineage ended. 5 million years of evolution, hundreds of thousands of years as an apex predator, gone. For over a century, we thought we understood the dire wolf, a big wolf, a close relative of the gray wolf. We were wrong. The 2021 genetic revelation showed the truth. The dire wolf walked a lonely evolutionary path, isolated in the Americas, diverging for millions of years. It looked like a wolf through convergent evolution, the same effective body plan emerging independently. Like how sharks and dolphins have similar shapes despite one being fish, one mammal. The dire wolf was perfectly adapted to hunt Ice Age megafauna. For hundreds of thousands of years, it thrived. But when change came rapidly, climate shifts, human arrival, prey extinction, specialists are vulnerable. The dire wolf couldn't adapt, couldn't interbreed, couldn't switch to new prey. The gray wolf could, and did. Today, gray wolves range across the northern hemisphere. They've survived persecution, habitat loss, climate change. They're flexible, adaptable. The dire wolf was none of those things. It was a terrible wolf, perfectly adapted to a world that no longer exists. And when that world ended, the terrible wolf ended with it.